So I wanted to talk about some of the motivations behind Impact. And being an open source developer, building state management libraries like Cerebral, after that Overmind, both of them which has been used and is being used by Code Sandbox, where I've been now at 4 years. I've learned a lot about doing state management for the types of applications that has a lot of client-side state to manage, like editor types of experiences. And as we moved into creating the new experience at Code Sandbox, you wanted to embrace React instead of using a state management framework. And doing so, it came clear what was the benefit of using a state management framework and what were the shortcomings of doing pure React. And the thing that's most important when you try to find a tool for the application you're building is to think about what kind of application are you building. So I like to think about this as a spectrum, where on one side you have, like on the far edge of one side you have e-commerce types of applications, and on the other side of the spectrum you have like productivity types of applications. This is just one way to look at it. But if you think about like a pure e-commerce experience, it's very much route driven. Like the user experience is they hit a route, they navigate through the application, changing the routes all the time. And as part of this, you want server-side rendering so that when you hit the page, you actually see something on the page immediately, and really as much as possible. Another thing is that these types of applications tend to target a very broad audience, also an audience on lower end devices. So you want it to be progressively enhanced. So they might be on old browsers and they might be on mobile phones and so on. Another aspect of these kinds of applications is that the users are mostly there for only a few minutes, as opposed to being there for several hours and even days. And you also want to minimize the data fetching. This ties back into low-end devices, maybe on a mobile network as opposed on a Wi-Fi network. But also you want to kind of spread out the data fetching so that you fetch at the perfect moment in time to keep a good user experience, but you minimize the data fetching. A very typical way to like measure if you're doing a great e-commerce site is if you have a great Lighthouse score. And that means basically time to interaction. How fast can you get the content on the page and make it interactive? And this is directly tracked towards how much money or how many products the users are buying. In terms of state management, it's not that much client-side state management. It's more like data management. Like how do you get the data down into the client in a way that's most efficient and also keep it up to date. Now, these kinds of experiences, they lend themselves very well to having very high-level abstractions because they're very similar in the way they need to optimize. So and do progressive enhancements and so on. So like libraries like Next.js or frameworks like Next.js and Remix and libraries like React Query, they work really, really well for these kinds of solutions. But then you have on the other side of the spectrum, you have these kinds of productivity apps. And here you don't do that much like route-driven navigation. You don't change pages all the time. It's more about like manipulating the URL. So what I mean by that is that you typically have some kind of editor-ish layout where you can change that layout and you want to keep that state persistent. And typically you do that in the URL. So in the URL query, you have some state related to the current page. Also, server-side rendering is not that important. You might render out like a skeleton, but you would typically do like a client-side bundle that actually fires up the application, because very little of it actually lends itself well to be run on the server. You can also target modern browsers, because you, like on the far edge of the spectrum here, you can't go without JavaScript. You have to have JavaScript to create these kinds of experiences. And also the target audience is more narrow and typically has higher end devices and modern browsers. And they spend a lot of time in these solutions. When they fire it up, they can stay in there for hours at a time and even have sessions that goes over several days. In terms of data fetching, it's since they spend so much time in the solution, it's perfectly fine to do more upfront data fetching to make the rest of the experience super snappy. Even though certain pieces of data is not used. The way you measure a success of this kind of application is not how fast you get to interactive, it's how performant the application is after it's been loaded up and the user starts interacting with it. Because of the UI complexity and the state complexity, you can very easily get into performance issues. And this is something you need to handle, because people expect like these web applications to work just as well as native applications. Another aspect of these kinds of applications is that they have a lot of client managed state. So there's just a lot of it, but it's also used across the application as opposed to localized in a component. The kinds of tools you would use here normally is more low level. It's more specific to managing state instead of encapsulating like data fetching and routing and everything. And this is what we're going to talk more about now as well. But before you think about what library you want to use, the tool you kind of have to think about first is like, what kind of programming paradigm fits best to solve the problem you have. And the problem we have is to deal with a massive amount of client-side state and a large code base. And depending on the team you're in and the company and the other kinds of implementations you have, doing object-oriented versus functional, like it's different. And this is not about like putting them up against each other. It's just figuring out which of these fundamental programming paradigms fits best to solve this problem. And at Code Sandbox, we have a lot of object-oriented code already. So we write some processes in Rust where we use an object-oriented approach. We have some processes that runs on TypeScript, which is object-oriented, but we also do have functional code. So for example, in our API, we run that on Elixir, and it's functional, and it fits really well for our API because it doesn't really manage state. The state is in a database or it's on Redis or whatever, and it just works really well there. And then we have React, which is also functional in terms of the component composition and everything. And that also works really well for React. But where React starts to create friction is when it starts managing state. So if you think about the hooks implementation in React, then you start seeing the friction that happens when you start managing state and also side effects in a functional way. I can just put a very simple example out. It's like, what if you want to have some private state? In the functional world, you would have to think about using closures. So it's more like how you do things. It's more like a pattern than an explicit concept. So opposing that to a class where you have an explicit private keyword to deal with private state. If you're in a team that knows object-oriented code and is used to work with object-oriented code, that can be a much simpler concept to approach, because as you know from React, as you start building on top of this, you start putting in effects, and we know how hooks and scopes and everything can become quite complicated. The question arises for us is like, is there a way for us to take the advantage of us knowing object-oriented code and use that with React? Because a thing that we also noticed, embracing React to the extent we have, is that it creates a lot of indirection in our code. So a very simple example of this is you have a component, there's something going on with this component, and it's related to its click. But this onClick comes from a property from a parent component. So you hold your command key, given you have a Mac, on your keyboard, and you click it, and you take in just to the props where you consume the props in that component. You don't go to the implementation of that onClick. So what do? Well, you search for references for that component, so you can figure out which parent component uses that component, it makes sense. But this is what happens. I'm just explaining how it works. And then you go there, and maybe that is passed from its parent props. And then you have to search for references there, and the story goes. And the same happens if you use context. If you don't have a concrete like class reference or something on your context, you'll try to maybe you have a function on a context. The logic for the onClick is rather exposed on the context, and you command click it. But now you're taken to the type definition of the create context call. You're not taken to the implementation of that onClick. And the same goes for dispatching. If you command click the dispatch, you're just taken to the dispatch. You don't know which reducer it is. You have to continue command clicking. If you want to figure out the action, you can command click the action. You have to copy the type for the action, and you have to search for the action name to find it in a reducer. And then you don't know what side effects actually runs related to that state being changed by reading the code. That's decoupled and expressed in some other component. So at Code Sandbox, we've experienced a lot of issues getting developers into the code and understand the code because of all of this indirection. As a final note, when it comes to debugging tools related to state management, there are a lot of amazing tools, like for Redux and MobX, and also Cerebral and Overmind has this amazing overview of the complete state of your application. You see a list of actions when state changes, and so on. But what none of these tools really do is tell you where did this state change occur, and if that state is observed, where is it observed from, like the line of code. And this is where we also want to, or was inspired to make the experience better, like debugging indirection. Instead of getting to the sources tab in your browser, what if you could, or you have to search the action name in your code base, what if you could just click something in the browser and you're taken to the exact point in code where the state change occurred, and also what components and where are components affected by this state change. So this is describing the challenges we have been facing at Code Sandbox and why we were motivated to see how we could take object-oriented code, like class-based code, and combine it with React so that we can get that full freedom to manage all this complexity in a paradigm that we know, but still embrace React for what it's really good at, which is composing and building up UIs. So that's it. Maybe your team doesn't do much object-oriented code. Maybe you don't like object-oriented code. That's perfectly fine. But I hope this gave you a sense of why this library was even built. And maybe you can take some inspiration from it regardless. Okay, thanks.